Thank you, Luigi. Yeah, so I'm Carlo Minotti from PSI, and I work in the data management team with another colleague of mine who's on holiday at the moment. And before we start going to the presentation, there will be two posters at 5, one from Klaus, who's sitting over there, and another from Max, and they both relate in one way or another to SciCat. So it's going to be SciLog, which is an electroencyclopedia developed at PSI, and the Expands and Panos project, which is a EU-funded project which has gone on for the last couple of years at least. Okay, a brief outline of the presentation. I'll try to explain what the role of SciCat is, and then I'll try to take the point of view of 3 groups of users, which are the users, the developers, and the inline scientists. Of course, there is some overlap between these users, but that's how to give a brief idea of what the capabilities of SciCat and functionalities are. So if we have a look at, let's say, a standard experiment journey, or the journey that the user takes when he's submitting an experiment and actually collecting the data, we see that we start with the proposal, then comes a planning, creation of the experiment, location of the files, then we curate the data, and then after the experiment has been taken, it follows the path where we access, process, analyze, and eventually publish a paper. So in this user journey now, if we zoom in, we see that as soon as we start curating the data, and the reason is because we later on have the interest of accessing the data catalog kicks in. So this is the idea in general of data catalogs. Then SciCat is one particular implementation of them. And of course, we will talk about that one. So in the end, what we can achieve with SciCat is basically a way to organize the data into these units, which are called data sets, which are the smallest unit that you can store in the database. Annotate them with scientific metadata and administrative, and those, of course, are of use to later search for the data. Then you can publish the data. Publishing means that after a certain amount of time, the data will become open, in the sense that it will not be under embargo anymore. So you can make them available to anyone who's interested in that. Both the metadata and the data can be downloaded. And then there are many facilities who store their files, which are taken during the experiment in their file system, but that can stay only for a limited amount of time. So many of them, they use SciCat to basically move this data to another place where they have a longer term storage. And then I said before, open data and embargo data. Now we go to the user's perspective. I said there are many overlaps. So a user, it's a very broad definition of a user. So when he goes the first time in the UI, he gets the login page as usual. And SciCat supports 3 authentication methods at the moment, which are default accounts that you can think of as administrative accounts. So basically accounts for which we have the password as developer, for example. LDAP, which is your Active Directory system. And we do have the OIDC protocol as well. And that's usually in place when you use Keycloak or sign in with Google or a single sign-on in general. So sign in with Facebook and so on and so forth. Later on, after authentication, we can see all the data sets that that particular user or any of the groups he belongs to acquired. This is basically a way to describe the experiment. So each of them you can think of as a way of describing the environment in which the experiment and the files were taken. You have some searching capabilities, and you can trigger some actions on top of that are over there. The authorization is based on group membership, and that can come from other systems that you have in place in your facility. For example, we use Duo to establish the group membership, which is then checked against the ownership of the datasets. So that means that different users see different data. You can edit the metadata. That also depends on your authorization, so the group you belong to. And as said before, you can trigger some actions in this bar over here. And this is the action I was talking about before. So moving and retrieving data from your facility to a longer term storage. and that's triggered out directly from the UI. And then you can publish data. This is the last functionality that I came up with for the presentation. So publishing means that this web page is available to anyone, and apart from giving a description of the experiment, there is also a way to actually downloading the files which were collected during the experiment. Now, if we jump to the developer's point of view, or maintainer, or the person who's going to deploy SciCat, we have in place this architecture. It's very similar to the one which was presented before. It's let's say kind of a modern web server application. So it has a backend and a front end. The whole logic, more or less, lives in the backend, and the data is persisted into this database here below. The front end is just a client which calls the suitable endpoints from the backend. So this list over here basically gives an overview of what you would have to do if you were to take SciCat in your environment. Whatever is not dashed, it's something that it's required for it to work, and whatever is dashed are additional functionalities that the SciCat stack provides, but let's say they are not fundamental to the working of SciCat. They all come they all come as a Docker container, so you can spin them up fairly easily. And there is a link here below which points to a GitHub repository which has a Docker compose, which basically spins up everything which is not dashed. So it would basically spin up the database, the backend, the front end, and it will fill the database with a set of pre-existing data. This is just an example. I will be fairly quick. This is the architecture we have in place at PSI. I won't go into much detail. The idea is only that SciCat being built into components can be, apart from being deployed on an on-premise infrastructure, can also be fairly easily deployed on the cloud. And that's what we do. And you still need, of course, some connection to the intranet, so to your facility infrastructure, and that can be achieved as well. And we did. We use Kubernetes, for which we follow a continuous integration. Here I will be very quick as well. So we use a monorepo approach, which has all the components that we use in SciCat at PSI. And this number over here and all the other digits are basically pointers to the version of the code that we want to deploy. And in this way, since we are actively developing SciCat at PSI, it means that we have full control on the code we deploy. We don't rely on changes done by someone else that we don't want to apply. Now, the last point of view, the ingestor's point of view. So I have to say that defining an ingestion mechanism for a facility is not a responsibility of SciCat. So all the facilities have different ways to ingest data. So that's left to every facility. But in general, the idea is that a beamline scientist, for example, would need to define a data set, which is the smallest unit for archiving, retrieving, and publicating. And this data set is basically the smallest thing you can inject into the database. It contains a folder structure in the end, which has some files inside, as you see here. And you don't have to define this folder structure ad hoc for just to work with SciCat, but you can reuse the structure that you had when you were collecting the data. Second thing the beamline scientist has to define is this JSON file, which is a set of key and values. And it's basically the metadata around your experiment. So a way to describe the experiment. So for example, these are environment values that you set up during your experiment. Relying on a Mongo database, the file is completely flexible. You can write whatever you want. There are some parameters which are, some fields which are indeed required, but in general, they are useful most of the time. So it's very frequent that you're going to add parameters instead of removing. And some of them, they can be automatically ingested by extracting them from other systems or from the files that you collected during the experiment. So as I said, each facility is responsible of building an automation for this. We at PSI came up with a set of CLI scripts that are given to beamline scientists, and then they can run. And that is their ingestion. Mostly because many of the parameters come from other sources and they don't have to write one by one. Future work briefly. I forgot to mention the technologies it relies on. So the backend, so this part over here, it's building a Node.js framework, which is called Loopback from IBM, Loopback free from IBM. Then here we have an Angular application, and okay, here a Mongo database. The rest, as I was saying before, it's left facility. Here on top as well, actually, we have an Node.js server and another Angular application in the SciCat stacks. Loopback free is getting dismissed by IBM, so no more support, and that's the, let's say, biggest share of work we are into, which is basically moving from this old technology, let's say, which is not old yet, but it's going to be old soon, to a newer one, which is Nest.js. Then the permission model that I was mentioning for the authorization model, it's going to be expanded, so it's going to be more roles. We somehow want to improve the usability of tables in the UI. That's kind of a detail. And then we are hoping, I mean, at least I'm hoping very hard to be able at some point to create a Kubernetes manifest, because that would have the same applicability as the Docker Compose file, but in a more production-ready environment, so Kubernetes itself. This would mean that you would have some files that you can run on your command line, and that would deploy automatically the stack on the cluster without you having to understand all the details. I'm close to the end. These are all the institutes that participate in the development of SciCat. Some active, some others are just adopters. You can, let's say, be on board, and if you're interested, there is this mailing list that you can write to, and for questions or just getting on board. And then there is a link to the documentation, which we try to keep updated, hopefully. And yeah, these are my thanks. Not everyone is in the picture, unfortunately. Some of the people have left, so contributed in the past to the project, and Tobias was taking the picture. Yeah. Thank you.
Thanks, Carlo, for this interesting presentation. You are perfectly on time. So we'll get a room for 2 or 3 questions if there's one there.
Nice talk. Thank you very much. There is just one question on my side from SciCat. Is there any limitations on the metadata? You said that you can extract metadata from whatever standards, for example, Nexus. Yeah. And I can imagine that in a Nexus file, I drop all the properties of all my experiments and devices and device properties. So it's tens of thousands of different kind of entries which I put in. Can you extract all and use the SciCat search capabilities, or do you have limits?
Yeah, so actually 2 parts to the answer. The one saying, like as I was saying before, this part is basically in the hands of each facility. So we extract the metadata we know of at PSI. Then if another facility has others, then they would have to come up with their solution. It's not, let's say, managed by SciCat itself. And also a problem we have is that we don't always use Nexus. So we have also many file formats.
Well, my question is only just on the limitations. So if I turn to happen that I want to extract 20,000 different properties from SciCat wise, there is no problem, no limitations. I can feed all 20,000 different experiments, and then I can search. Or,
I mean, there are, let's say, load balancer body size limits, but apart from that, I don't think. I mean, there might be bottlenecks in the database, locking the table and ingesting the data. But
it's not a limitation of the
implementation. No, it might be a limitation of the infrastructure, and we haven't. I mean, we have encountered a limitation in in the load balancer body size because people were uploading how it's called, basically the bytes of an image, and that would be a very big object for. But in the end, you can always increase. I mean, we always solved up to now by increasing that.
Thank you.
Any other question? No, so thanks again.
Thank you.